let's go to the second part here, which is approximate zeros. So approximate zeros determine between which value. Approximate zeros, as you can see here, let's determine between which consecutive integers the real zeros of each function are located on the given. Okay, now let me just give you a brief about the approximate zeros are talking about what. Okay, here we know that the zeros, what are the zeros means? The zeros mean x-intercept. So where is the function intersect with the x-axis? Means if I have here, sorry. So let's say if I have, this is y, this is x, okay? Now, example, if I have this function here, okay, this function is going up, this function is going down. Now, as you can see, how many points this function is intersecting with x-intercept. So as you can see, this one here, and this one here, and this one here. So I have 3 zeros, right? Now, if I ask you, I need only the zeros between this value, which is example 1, and here, let's say it's 5. Now, if you ask you how many zeros in the interval between 5 and between 1, you will tell me it's 2 zeros. We have 2 zeros. Why? Because it's within the interval 1 and 5. So we exclude the third zero here. So this is the approximate zero means. We are going to find how many zeros between two interval. Okay, but we are not going to find the exact value for this. I need only, okay, between which two numbers is equal to 0. Now let's read the question, or let's look to the first example. Now, how do I differentiate if this one there is a 0 between this or there is no a 0 between this? First, for sure, of course, if you check this one here, okay, now look to the y-axis. So now if I have example this line here, so this point here, this is a 0, right? Now what is the number, okay, before the 0, which is here? So this point here on the y-axis is what? Is positive. Okay, after the 0 here on the y-axis, what's happened here? It's negative. So as you can see, if the number is before that number is positive or after that number is negative, which is the numbers between positive and negative, so for sure there is a 0 here. Okay, so when you can see positive and negative, for sure there is a 0. Look to this one. This is x, -4, and y is -46, -3, -13. So is there a 0 between -56 and -13? No. Now let's go to -3 and -2. So -3 in the x, you get -13. -3 in the x, -2 in the x, you'll get 2. So as you can see, this is negative, this is positive. So for sure there will be a 0 between this. Okay. Now, between 2 and 5, there is no negative. Both of them are positive. 5 and 2 positive. 2 and -1. So as you can see, for sure, positive and negative, for sure, there will be a 0 here. Now, between -1, 2, yes. So there sure will be a 0 here. Okay, 2, 17, 17, and 15. So all of these are positive. So as you can see, how many 0 do I have within this interval from -4 to 4? Okay, so from -4 to 4 I have 3 zeros. So how do I write this one? So I can rewrite it from -3 less than x less than -2. So this is the first interval, and the second interval is between 0 less than or equal x less than or equal 1. So I have here this interval. Okay, we're looking only to the x's. The third x is between 1 and 2. So between 1 less than x less than 2. So this one is the third interval. So this is what you can see here on the right side. So the first one here is between -3 and -2, which is this one here. Then I have between 0 and 1, which is this one here. And I have 1 and between 1 and 2, so this one here. Okay, I hope you understand this. Now let's go here to this expression. Now if you need to make the table, you have just take the domain or the interval, write it on the left and the right from the smallest to the largest. Now just pick the small point, -2, -1, 0, 1, and 2. Now plug these point in the equation. Okay, so now x is -3. So if I replace -3 here, okay, -3 squared plus -3 plus 0.16. So -3 squared is equal 9 minus 3, which is equal 6. 6 plus 0, so 6.016, right? Now if I replace negative 2, so it will be 4. 4 minus 2, 2. So it will be 2.16. Negative 1 replaces would be 1 minus 1, 0, so 0.16. If I now replace 0, so 0 it will be 0.16. If I replace now 1 squared, 1 plus 1, so it will be 2.16. 4 plus 2, 4 plus 2 is equal 6, 6.16. Okay, then 3 which is 9, 9 plus 3 which is equal 12, 12.16. Okay, so those are the table. Now check now the values. Do I have a negative between these two values? No. Do I have negative here? No. No. So as you can see, there is no negative at all between any two values. So what should I do when I have no negative? Should I write there is no zeros? No, don't try this. There is another rule. When you have two repeated value, for sure there will be a zero between them. Okay, or you have to check at least. So between 0.16, 0.16 here, they are repeated. So between negative 1 and 0, there will be a 0 here for sure. So how can I know? I have to pick point between negative 1 and 0. So just pick any point. So I will pick negative 0.5. So now let's replace negative 0.5 in the function. 0.5 squared plus negative 0.5 plus 0.16. Okay, so now if I replace these values, so it will be negative 0.5 square, it will be the, okay, well, the plus minus, so the answer is negative 0.09. so as you can see, there is a negative. So as you can see, between 0.16 and negative 0.9 there is a 0, and between 0.09 and negative 0.16 there is a 0. So the interval will be 0, sorry, not 0, we looking to the x's, between negative 1 less than or x and less than 0, okay, and also between the 0 and between negative, only this interval. What I'm talking about, I'm sorry. So the interval is between only negative 1 and 0. Okay, so there will be a 0 here. But when we need to write it here, sorry, I forget. Okay, here. Now the first interval will be between negative 1 and negative 0.5. Negative 1 less than or equal x less than or equal negative 0.5. So this is the first 0. And between also negative 0.5 and 0. Negative 0.5 less than or equal x less than or equal 0. So as you can see, I have 0 here and I have 0 in this interval. Okay, I hope you understand this. If you have any question, please tell me. Try to solve now this question by yourself and practice on them. Here I missed something. The interval for this point is from negative 2 to 2. Okay, now try to solve this. Okay, now the last thing here is which is the end behavior. So as you can see, the end behavior here, we're talking about something easy. Okay, let me just explain it to you here so quick. So if I have y and I have here x. Okay, so now we know that this is 0, 1, 2, 3, 4, 5, 6 to positive infinity. So here is x approaching positive infinity, and on the other side negative 1, negative 2, negative 3. So now here x is approaching what? Negative infinity. Okay, now same thing for the y. Here y, when it's going up, f of x is approaching what? Positive infinity. Here on down, f of x is approaching what? Is approaching negative infinity. So you have just to look to the function. Where is the function go? Is the function is going up? Okay, so that means positive infinity. If the function goes down, it's negative infinity. So example, if the function goes like this, so that's mean when x approach positive infinity, f of x goes where? Positive infinity, because both of them on the positive 1. Now if the function goes on this side, so that's mean when x approach negative infinity, so f of x goes where? F of x goes to positive infinity. Okay, same thing will happen when I'm talking about this here. So the same thing when x is negative infinity, y f of x is negative infinity. Okay, here and on the other side, okay, when x approach positive infinity, so f of x is approaching negative infinity. Okay, I hope you understand this. But here, because you know that you learned that we are x approaching example positive infinity, let's talk about the green one. If x approach negative infinity, because this is what you learned how to write it in integrated math. But in a pre-calculus, we don't write it only this. We have to add lim of f of x when x approach negative infinity. So you have to just write, where does the function go? Is it going up? Yes, it's going up, so it's positive infinity. Okay, let's do the red one. So how can I do the red one? So you have to write it as limit when f of x approach what? Positive infinity. So the question or the function goes what? Positive infinity. Same thing for the yellow one. Limit of f of x when x approach what? Negative infinity. So the function goes down, which is equal negative infinity. So this is how we can write it as a pre-calculus, students. Now, if you look here, the graphs that approach, okay, infinity, support the conjugate numeric. I will not ask you for support numeric, so forget about numerically. Just now focus on the limit. Now, so as you can see, the function on the right, okay. Now, if I ask you this, limit when f of x, when for f of x, when x approach positive infinity. So this is x positive infinity, right? So the function goes where? It goes down, so it's negative infinity. Now on the other side, when x approach negative infinity, so when limit of f of x, when x approach negative infinity, the function goes where? It goes down. So that means negative infinity. So both of them are negative, so that's what you can see here and here. Okay? Let's take one more example. Okay, look to this one. So now what is the limit for this one here? So now when x approach positive infinity, limit of f of x when x approach positive infinity, the function goes where? Move with the function. If you can see, the function goes like this, approaching beside the x-axis. Okay, it's not intersect, it will never intersect, so it's approaching what the value on the y? It's approaching 0. So we can't say approaching negative infinity because it's not going down, it's going with the 0. Okay, now the other side, which is negative when limit of f of x when x approach negative infinity. Okay, so move your function, so the function will go close to the x-axis, still also is going to the 0. So from the right is from 0 and from the left is 0. So this is what you can see here, okay, for both the negative and the positive. Okay, I hope you understand this. Okay, try now to solve and practice on this equation, and if you need any help, please let me know. And this is the end of the lesson. Try to solve this question from question to question 31 on the pages 30 and 31. Okay, so you don't have to solve more than this. Have a good day. See you. Bye bye.